Greetings students. Today we're going to get a bit of an idea of how to do reduction-oxidation reactions through the half equation method. This will be done in an acidic environment, so we're going to have protons available. So what we're going to be looking at is following the set of rules that will allow us to balance a reduction-oxidation equation. Now normally when you receive one of these equations you'll get the beginning and the end species and you just need to fill in the middle. So we'll start off with two of the most common that you're going to get in stage 2, and if you learn them now it's going to be much easier. So it's MnO4-, which is the permanganate ion, and that becomes Mn2+. So step 1, balance the element being oxidized or reduced. You look on the left and we've got one manganese, and you look on the right and we've got one manganese. Good, that's already fulfilled. Step 2, add water to the side deficient in oxygen. You look over here, you've got 4 oxygens, you look over here, you've got none. So we need to add some oxygen to that side. So we're going to add 4H2O. We need 4 waters because it takes 4 waters to give you 4 oxygens. Okay, now we add protons to the side deficient in hydrogen. Well, 2 times 4, so 2 times 4 is 8, so we're going to need 8 protons on this side plus 8 H plus, and then you add electrons on the side with the highest total positive charge. Now if we look at the two sides here, over here you've got an Mn2 plus and water is neutral, so that's not charged. So overall the charge over here is 2 plus. On the left hand side however, you've got a permanganate which is minus, and you've got 8 protons which are pluses, so you've got 8 pluses and a minus. So overall the charge here is 7 plus. We need to turn 7 plus into 2 plus. How do you do that? Well, you need 5 negatives. So we're going to have plus 5E minus. Now we can see here that this is an example of a reduction reaction because reduction is gain. So you can see here that the electrons form a part of the reagent side of the equation, and it's going to produce the products. And it also requires these protons to be able to proceed, which is why we say it's in an acidic environment. So in this condition here we can see that the manganese, if we were to look at the oxidation number, 4 times 2 is negative 8. How do we go to negative 7? Well, we're going to need negative 7. How do we go to negative 1 from negative 8? The manganese over here is in a plus 7 oxidation state, and over here it's in a plus 2. So you can notice that if you get your 5E minuses and shove them onto the manganese here in the plus 7, then you're going to end up in a plus 2 state. So that's where the oxidation is, the reduction has come from, and you can tell that the manganese is reduced because it's gone from plus 7 to plus 2, so it's gone more in the negative direction, and reduction is going to electrons through the whole oil rig thing. Now you need another equation to go with it, so let's do iron. Fe2 plus becomes Fe3 plus. And you might be saying, where's Mr. Turley getting these example reactions from? Well, I'm getting them from the stage 2 curriculum content. You know, you can use a lot of different things to reduce and oxidize. These are just 2 examples of a multitude of different equations that you can use. But I'm using these because these are the ones that you've got to be able to spew out onto paper in stage 2. So when we look at iron 2 plus going to iron 3 plus, they're 2 forms of stable ion ions, and here we've got to apply the same rules. Balance the element being oxidized or reduced. Well, there's one on either side, so that's all good. Next step, add water to the side deficient in oxygen. There's no oxygen on either side, we skip that step. Add protons to the side deficient in hydrogen. There's no protons, there's no hydrogen, we skip that step. Now we've got to balance the charge. So it's 2 plus on this side and 3 plus on this side. So in order to do that, we need to add an electron. Add a minus to 3 plus, you get 2 plus. So that's what's happening here. The ion is giving away an electron, it's becoming a 3 plus ion and letting an electron go at the same time. Now as you can see here, this one's reduced, the manganese, and the iron is oxidized because oil rig oxidation is lost. So when you've got an electron on the right hand side and on the left hand side, now you've got 2 half equations that can be put together. And they're referred to as half equations because half of it is oxidation, half of it is reduction. So we've got to put them together, but in order to do that, the number of electrons must balance on either side. So this one's got 5 electrons, so this one's only got 1. So in order to add these two equations together, we need to times the bottom equation by 5. Now we're ready to add them together. MnO4 minus plus 8H plus 5E minus plus 5Fe2 plus. So that's everything from the left-hand side of the equation, from the top one and the bottom one, making sure that I times the ion by 5, because we've times that entire bottom reaction by 5. And now we've got to do the right-hand side, so it's going to be Mn2 plus 4H2O plus 5Fe3 plus 5E minus. Okay, now we've got both half equations added together. And in the situation where you've got the same chemical species on either side, like electrons on either side for example, you need to do what's called the hack and slash step. Not so obvious in this equation, because when you look on the right and the left, you don't have H's there and H's here and waters on either side. So there's not a heap of chemical species that are going to get cancelled, but you can certainly cancel out these electrons because it's the same thing on either side, making the final equation MnO4 minus plus 8H plus 5Fe3 plus makes Mn2 plus 4H2O plus 5Fe3 plus, and we're done. So just to make sure that we get it all on film here, I'll get the camera to zoom in a little so that then you are able to pause this video and take down these notes if you wish. Thanks for watching. Stay safe, maintain your social distance, and I don't know, wash your hands after you use the toilet.